All right, so for exercise 6DFG, what you take out of it is, now I'm assuming up to this point, if you're up to DFG, you're now learning, or you learnt exact values and you have an idea of symmetry properties. Then now you're applying it to graphs. Now the two graphs you start off with is a sine and then a cosine. The difference between the two. So usually I tell my students to memorize one cycle. Here's one cycle of sine. You start at 0 and you finish at 2 pi. That's a nice cycle to compare with cosine. Cosine is this one, starting at 0 again, and you finish at 2 pi. But hopefully you see the difference between the two. Cosine starts at the maximum, sine starts at the midline. Okay, so if you're starting off with graphs, this is at least the basic shape for sine and cosine that you must know. Transformations, chapter 3. All of this is still the same. You can copy that down. It's on OneNote, or hopefully at this point you can read them. C will govern whether it goes up or down. A is a dilation, but because the graph is sinusoidal or cosine, it's got a oscillating behavior, that's why it seems like there's a cap. We call that the amplitude. N is also a dilation. It's a compression from the y-axis. That's why it affects your period, so how long it takes to make one cycle. That's why it's times by 1 on n, and hence the formula is 2 pi on n. That's where it comes from. And lastly, x minus b moves the graph left or right. Okay, so all the transformations are the same. These two parts, that's the reasoning. Dilation stretches vertically, that's why it's your amplitude. That's a dilation or compression horizontally, that's why it affects your period. And that's where the rule comes from. The fact that you're multiplying by 1 on n. Okay? Now, if you had to take something out of these two, period, you need to know the formula to find a period for sine and cosine. I'm going to summarize it for you. Sine, cosine, you need to know the period, 2 pi on n. That's number one. Make sure to have those notes if you're not familiar with it. And then number two, A determines the range. Okay, so the range is determined by A. A is the amplitude. So if you don't know that, write it in. But if there is a vertical translation, like a plus C, that also affects your range. So I summarized it for you down here. Range is C, whatever C is, minus A, so minus the amplitude, and C plus the amplitude. That should tell you the range of sine or cosine. Okay? So if everything I just described was confusing or you're unsure at this moment, make sure to have period, amplitude, range. The rest we can pick up. Okay? So, amplitude, period, range. Highlighted it for you. Okay. Let's do an example that you will start practicing at 12. It is a lot faster than year 11, so we're jumping right into it. Here's an example. Let's see if you guys can see the amplitude. Work out the period. And the range should be pretty straightforward as well. So here we go. Start from the right to, I think we've got a lot of special students here actually. So we'll just go from the right. Krish, what is the amplitude? 3, very good. 3, so the dilation factor in front of the function, that dilation tells you the amplitude, so we know it's 3. Period, let's go to right. I think Vibert does special as well. Let's go with Erwin. What's a period? How do you find out? Pi, very good. It is 2 pi on n, which is 2. 2 pi divided by 2 is pi. That is correct. Next one, range. How do I calculate the range? Let's go with Samar. Good. In this case, I don't have C because there is no vertical translation, but A is 3. So what's the answer? So if I don't have C, C is 0. Good. So it's from C minus 3, which is 0 minus 3, and 0 plus 3 gives you a range of -3 to 3. Okay, which makes sense because I haven't moved the graph up or down, but I have dilated it vertically. So the height reaches 3 and the minimum reaches -3. Okay? All right. Let's read the transformations. We've got dilation, we've got a compression, which makes sense why the period is pi. What's the x minus pi on 4 do? Let's go with who's another non-special, Aryan. Reading this bit. What's the minus pi on 4? Tell me. Beautiful. Moves to the right by pi on 4. So I'm shifting this graph to the right by pi on 4, which is over here. So think about a sine cos graph. Cos graph normally starts at the maximum. And so it looks like this. Starts at the maximum 3, -3. But now you're shifting this to the right by pi on 4. So 3 at pi on 4, this is what it should look like now. Everything shifts across. So normally this would have been at pi, and this one would have been at 2 pi. That means pi plus pi on 4. At 5 pi on 4, I should have the minimum. And then obviously the maximum will be past the domain. The domain's only 0 to 2 pi, but it should have been somewhere over here, and this would have been your nice one cycle. But the problem is, remember, the period is not 2 pi anymore. It is now pi. Okay, the period's shortened. So this is why what you're doing here would be incorrect. So what you need to start off with is to figure out, well, we've got a starting point. How do I work out the shape of the graph? Now, there's a lot of ways. Your teacher might have taught you differently. I don't mind which way as long as you get the correct shape. The way I normally teach my students is to find the quarter periods. Okay? So if you think about your normal cos graph or sine graph, they're all split into quarters. So you can see here, I'm going to split into a quarter for you. This is at pi on 2. Then the next quarter is at pi. The next quarter is 3 pi on 2. And then the last quarter is at 2 pi. That is representing your unit circle. 0, pi on 2, pi, 3 pi on 2, and then 2 pi. Okay, that's why I'm getting those quarter cycles. If you can work out the pattern, how long does it take to get to pi on 2 or quarter cycle, to the next quarter cycle, to the next quarter cycle, you can actually figure out what the graph looks like. Now you told me the period is pi. So one full circle is pi distance. So if you want to do a quarter circle, so I go QC, so quarter of a cycle, quarter of pi is pi on 4. So that means you are working on a unit circle where if you start at 3, at this point here, pi on 4, you've got 3. To get to the next quarter cycle, I know that it moves an extra pi on 4. So think about it. If I move an extra pi on 4, it goes from maximum, so notice here, maximum, to the midline. Next quarter cycle brings you to the minimum. Next quarter cycle brings you to midline, and then next quarter cycle brings you to maximum. So there's a pattern. So it goes max, middle, bottom. Middle, max, middle, min, middle, max, middle, min, middle, max, middle, min. It just keeps going like that for every quarter cycle. But you worked out every quarter cycle is a pi on 4. So this is what it looks like. Here we go. After I move a quarter, it should hit the middle line. After I move another quarter, it should now go down to -3. After I move another quarter, it should now move to the midline. After another quarter, I should go to the maximum. After another quarter, I should hit back at the midline. And after another quarter, I should hit minimum. And another quarter, I hit midline. Can you see how all I'm doing is once I've learnt it's just one quarter cycle, Here's my graph. Cost graph looks like this. That's one cycle. And all I did was max, middle, min, middle, max. How did I know each one? I worked out the quarter cycle. That's what the quarter cycle helps you to do. And you follow it again, it goes like this. So the next part, if you went a quarter back, the quarter back should hit middle. So this is what your final graph should look like. You see, that's all I did was I started off with the key point. I started off here. You told me to the right by pi and 4 doesn't go up or down. So the cost graph looks like this, or starts off at that point. Then all I did was I said, how do you go from max to the middle, which is a quarter distance? You worked out this quarter distance to be pi and 4. So I just went, all right, well, from this point, that's at pi and 4. Pi and 4 plus another pi and 4 makes pi and 2. So at pi and 2, I should hit the middle. Afterwards, I said, what's the next quarter? So pi and 2 plus another quarter gives you 3 pi and 4. I should hit the minimum. So there we go. At 3 pi and 4, I hit the minimum. Then I do the same thing again. So from this point, I add 3 pi and 4 plus another pi and 4, should get to the middle. And then the max, middle, min, max, and you can keep going. So it doesn't matter what type of graph I give you. I can even give you the one on the next page. This one is the full transformation. This one has amplitude, dilation from the y-axis, and vertical and horizontal translation. But all you need to figure out is the first point. If you know the first point, work out the quarter cycle, you should be able to plot and get a visual image of what it looks like. Yeah, it's a bit more tedious to do compared to the intuition. But for a lot of students at chapter 6, I noticed that intuition is not strong with circular functions. Okay, so I'm giving you a process that allows you to get there, to visualize endpoints and movement. So this is what I did for the graph I'm going to show you. Here we go. Here's example 2. And this is probably the most that you got to do if you had to do it by hand. You'll have the full transformation. And now here we go. Let's read the period. Period is the same thing again. 2 pi on 2. So we know a full length, a full circle is pi. That means every quarter cycle, you need to move pi and 4 distance. Okay? Then I say this is a sine graph. Here we go. Sine graphs normally look like this. So your starting point is at 0, 0, but let's read the transformations. Here we go. Let's read. What's a minus 1 tell me? Let's go with Alicia. What's the minus 1 tell me in terms of transformations? Down 1. So if you think about this graph, from the 0, 0 point, I just went down by 1. Then you read the next one. Now be careful of this part. There's a dilation there. So what is the translation? Very good. This is left by pi on 2. So if you think about it, we said down by 1, left by pi on 2. So in this normal graph, it would have been gone down by 1, left by pi on 2. But remember, the maximum minimums was negative root 2 and then root 2. Right? Obviously, we haven't accounted for the minus 1s. Yeah, but in terms of the amplitude, it's root 2 distance. So now we follow that down by 1. So I shift the very first point. I shift it down by 1. And then I go left by pi on 2. That means at negative pi on 2, I should have the very first point right there. Okay, so if I zoom out, can you see what I've done here? I'm just going to rub this one out so you don't get confused by all of this. Do you see what I've done here? I've chosen the very first point as negative pi on 2, negative 1. See that very first point. All these other ones I calculated. I'm just going to rub out so you don't follow that. Let's see how I found all these other points. Here we go. So I found my first point. How did I know it was here? Based on the transformation. All I did was just read it. So from chapter 3, you read the transformation. You said down 1, left by pi and 2. That's what I did. Down by 1, left by pi and 2. We know the sine graphs should go from middle to max to middle to min to middle again. We know that to get to the maximum, which is from the middle line here, that very first point is the middle line. To get to the max, it's a distance of pi on 4. So here we go. Let's look at where pi on 4 should be. So if I'm starting at negative pi on 2, for those who aren't good with their fractions, in terms of quarters, this is 2 pi on 2, so negative 2 pi on 4, sorry. If I add pi on 4, because I'm moving by a quarter period, moving from this point, moving a quarter period, would mean that I'm going to negative pi on 4. Negative pi on 4 is where my maximum should be now. Okay, so I know where the middle line is, the starting point is for a sine graph. I just now need to know at a quarter cycle, where's my maximum? So here we go. Let's think about the range. Maximum is clearly on negative pi on 4. We just don't know where we're putting it. Now, what's the range? Range, you already know. C, which is negative 1, plus A, which is your amplitude, and then negative 1, minus and plus. Whoops. Minus root 2 and plus root 2. Here we go. Now let's estimate. Negative 1 minus root 2. Root 2 is roughly how much? If you had to guess. 1.4, 1 point something, right? So negative 1 minus 1 point something should bring you into negative 2 point something. This case, negative 1 plus 1 point something, okay, that should give you just a bit above the x-axis. So it has to be below 1, and it's somewhere in this region. Okay, so the estimate is roughly up here. So you don't know where it is exactly, but you can get a general view. Okay, so negative 1 plus negative 1 plus root 2. Let's estimate it. Let's say it's here. Then the maximum point must be around here. Negative 1 plus root 2. So this is your middle line. This is your max line. And negative 1 minus root 2 should be negative 2 point something. So roughly there. So we did an estimate. Negative 1 minus root 2. We've got the mid, up, mid, down. You can then follow that pattern to draw your circular function. So here we go. We start off with the first point. After a quarter cycle, I reach the max. After another quarter cycle, I reach the middle. After another quarter cycle, I reach the minimum. After another quarter cycle, I reach middle. Another quarter cycle, I reach maximum. You see what I'm doing? All I'm doing is I'm just following that shape. And if you did it all together, you get your sine graph. So that's what I mean. You just need to know the shape of your sine, find the very first point through transformation, and then follow by every quarter. Every quarter cycle, you go max, middle, min, middle, max, middle, min. And you can keep going to the right and left to figure out roughly the shape. And then you can also figure out endpoints as well. Okay, so here we go. If I follow on, again, this would now bring me to roughly there at pi. And if I continue on, that's max, min. So that means it goes to the minimum down here. And then at negative pi, it reaches there. So if I put it all together now, that would be if I have a domain of negative pi to pi, and that works out nicely. Okay, and there'll be points where it won't work out nicely, but then that's when you add in to find your endpoints. But the shape, you should be able to figure out just from quarter cycles. So I haven't really added much to your knowledge. I said 3 things to know: amplitude, period, and range. And then what I'm teaching you here is just using quarter cycles. Yes, and once you know the quarter cycles, you can figure out from the midline for a sine graph. For a cos graph, you start at the maximum. That's the only difference between the two. So here you go, I'll draw it again. Sine graph starts at the midline. That's sine. Cos graphs start at the maximum. So as long as you know the first starting point through transformations reading it, then you use that first point and then you just find every quarter cycle. And that's how I find max to mid to minimum to mid to max. Versus this one, mid to max to mid to minimum to mid. And that's all I'm doing. I just literally follow the distance of quarter. Now, why did this work out nicely? It's because my x-axis. I worked in pi and 4s ready for you. If you want to be generally like your axes to work out nicely, just goes in pi of 12s. Pi on 12s is the multiples that you would get for 6s, for 3s, and for 4s, and it'll always work. So if you made your x-axis all out of pi and 12s, no matter which one you get, you can sketch. Okay, so that's what DFG. Don't do too many of them, but you have to do the hard ones. And if you can do the hard ones, you can do the easy ones. Okay? That's it for today's lesson. It's all about quarter cycles. That's how I normally teach my students. Obviously, x-intercepts. This one we'll do next lesson. Okay, x-intercepts, I'm going to rely on the fact that you have to learn symmetry properties. Without that, solving x-intercepts you can't. But I'm going to write the solutions up for those who are familiar with solving x-intercepts. I'm going to write the solutions up, copy it down if you don't know how to do solving x-intercepts. Okay? There you go. I'm going to pause the video soon. I'm going to write the solutions for x-intercepts up here for you to see. Let y equal to 0, root 2, sine of 2x plus pi minus 1. Move everything across, so 1 on root 2. Equals to sine of 2x plus pi. Sine inverse 2x plus pi equals to the sine inverse of 1 on root 2. 2x plus pi is equal to 1 on root 2 is pi on 4. So you got 4 and 3 pi on 4.
But I think he did a shit commentary.
Yeah, no, Alpha said his commentary, no, not Alpha. Sorry. Hayden said his commentary was like a sub 40.
What'd you guys do?
I didn't go to.
No, you didn't go to. I mean, I went today.
I'm just waiting until 3. I don't want to talk tales about it. I don't like it.
That's actually such a nerve getting.
He's chill, bro. If you don't have him as a teacher, what do you write about it? It's full of life. Yeah, 34. Don't worry, Coach. I'll have to check.
Instead of squaring everything to get rid of the root, I kept rooting.
I read the second page of my commentary was like dark shit. Brain really dark shit.
So, when you have a moment, can I ask you a question?
Yep.
Yeah, well, I was like shocked at that. I'm just not gonna do anything. Are you sure? Are you sure? Yeah, it'll be fine.
So, what does this give you? Negative 3 plus 8.
That's pretty smart.
Colin, how'd you go?
We'll find out at 3. Last check.
Plus 8 is 5 pi on 8.
What they said, I took
Yeah, that's what I did. I really late, but then it was like, I thought we could get the bottom line.
No.
Of like the page and all the other stuff.
That's what I
I really
said.
Plus 8. 5 plus 8 is 13 pi on 8.
Yeah.
And then 7 pi plus that's 15 pi on 8.
Can you actually?
No. I've been here for like fucking.
I got
That's
pretty
good. Why is it so jacked? Because I know my first language.
That's such color. It's the
Color,
not my best language.
no, but it is Cole's first language because it doesn't know any other language.
No, he knew Bulgarian.
Yeah, he knew key word.
Yeah. So it wasn't his first language. now.
Yeah, but not, so it's like,
Alright, so what's the domain? Negative pi to pi. So the ones we take.
To writing because you still have it to the boundary.
Can you run on loose leaf and then I'll just take photos of those ones?
I mean, like right now.
Yeah, so I can give you loose leaf.
Okay, yeah.
It's my loose leaf.
We just get it back like as soon as every class comes.
Well, today's the last session that everyone should have done it, but then I reckon there's students who rescheduled and haven't done it completely as well. So hopefully by Tuesday, but for now.
We have to do
The x-intercepts are negative 3.8, negative pi and 8 to 5 pi and 8 to 7 pi and 8. So there should be 4 intercepts. Let's see. And yes, we do have 4 intercepts. Cool. So you can label them negative 3 pi and 8. What's the other one? Negative pi and 8 to, what's the next one? 5 pi and 8. And then last one here is 7 pi and 8. There we go. Those are the answers for the x-intercepts. If you got them right, well done. This should be your 4 x-intercepts. If you were able to calculate it. And there's many ways to calculate it. You don't have to do it my way. It's just the most direct way I teach my students on how to do it.